Hello, welcome to another episode of the Data Science Leaders podcast. I am your host, Dave Cole. Today's guest is Anand Rao. Anand is the global AI lead at PwC. He has over 25 years experience in data science, primarily in the research and consulting space. He also has a PhD in AI from the University of Sydney. Anand, welcome.
Great to be here. Thanks, Dave. So thanks for having me on your podcast.
Yes, we have a few exciting topics today. We're going to talk about responsible AI. What is it? Why as a DSL should I care about it? We'll also be talking about consulting in AI. You have a number of years experience in consulting, so we'll answer the question, if I were starting a data science consulting practice today, what are some tips and tricks that you would give us? And then the sort of recurring topic on the DSL podcast is ROI and AI. So what are some things that, as a DSL, that I should be thinking about? And I think you got a unique perspective there. But before we dive into those interesting topics, one thing that I can't help but comment on is that you received your PhD in artificial intelligence from the University of Sydney. I don't want to date you, but it was sometime in the 80s. And like that's pretty rare, right? To have an advanced degree in the world of AI, I think, way back in the 80s. I was just a young boy and had no idea what AI was at that time. But I'm curious to hear from you, what has been the difference in AI based on what you learned way back in the day in college versus today?
Yeah, no, very interesting question. So yeah, it's a very different world now versus what we were in those days. I would say a couple of key differences. So we didn't have as much data as we have now, as we all know, right? So since the 2000s and obviously with the internet and with all of the things that came back. In fact, I remember it was ARPANET, so the prelude or the precursor to the internet was what we used to use in the academic network. So data was definitely much lower, hard to come by, and very structured pieces of data, as opposed to all the things that we have now: images, video, audio, and the whole lot. So that's one difference. But to me, the other major difference is also, I would say, the notion of open source. Now, I think as a data scientist, you almost never start anything from scratch. You always have libraries to build on. In fact, you have your own multiple pieces of code to build on, and it's all open source, and everyone knows about GitHub and all the things that you can get from there and build on other people. So those days, none of them existed, right? So it's almost starting from scratch. So to give an example, if I had to build a natural language processing system or NLP system, if you like, I had to completely understand everything and build from scratch. I mean, I need to get the data, that's definitely one, but then I need to understand English grammar, right? So I need to build the parser for it, right? So from the scratch, right? So you have to build so much of machinery, and given that none of that was available freely, the papers, of course, there are lots of academic papers, but still it's not code, right? So you still had to build all your code from scratch and then start working further. Whereas now we all are so used to pulling data, pulling code, pulling different things, and then essentially going on. So in that sense, it's sort of very different. The third thing I would add also is the compute power, right? So of course, the things that we are doing today in my area of specialty is agent-based modeling, agent-based simulation, multi-agent systems as it was called then. So then we could run only so much of compute. Now we can run millions of these customer agents, make decisions and so on. So those days it was restricted to a few dozen or maybe maximum a few hundred. So very different world in terms of compute, data, and open source, I would say.
Great. Well, let's move on to responsible AI. So what I'd like to start with is, as a DSL, why should I care about responsible AI? I mean, are there any laws out there? Are there any regulations that I should be aware of?
Yeah, responsible AI, I think there are a number of sort of related terms that people use. One is, as you said, responsible AI. Other terms that you would you would come across is ethical AI, and I know the European Union also uses trustworthy AI. Some also use beneficial AI. So all are, I wouldn't say they are the same, but they are related concepts. And I guess as a data scientist, the reason why you should pay attention to any of these words is that as data scientists, we have been very focused on making things work, right? So give us a problem. I mean, give me a prediction problem, give me a sort of a forecasting problem, recommendation. How do we get the accuracy, the best accuracy, given the data? What kind of data do we need? How do I improve my accuracy? What are the different algorithms, and how do I choose between these algorithms? Very, very focused on performance, and very specifically focused maybe around the accuracy, various metrics of accuracy. Now, I think what all these terms, responsible, ethical AI, and all of that have raised, if you like, the issue is more around when and how do these models get used by people? Who are the people who are going to be using them? And how are they going to use them, and under what context, broader context it's being used? And because that societal way in which these models and these algorithms, data science algorithms are embedded, can have a number of potentially negative implications, so risks associated with them. And as data scientists, while we are building the model, we should also be very conscious and aware of the context in which our models are going to be used. And that's why I think we need this broader framing. Again, examples that people talk about is, of course, for machine learning models, you're building them based on the data that you have, the historical data that you have. And if the historical data is biased in some way, right, so either in terms of a time or in terms of the overall cohort, then your model is going to be biased. So no matter what your accuracy is, it could be very high accuracy as it relates to that given data, but if that data itself is biased, doesn't matter how accurate you are, overall, it's not going to be satisfying from a societal perspective. Just one example. Explainability is the other thing that people talk about, right? So now we have built a model. Who is using it? If it's an end consumer, is it a statistician? Is it another data scientist? So based on that, you need to give the right explanation, and you can use different types of models to, in fact, explain or to do the primary task. So those things become important. So I think many of the communities, what they have been looking at is what kinds of constraints, guidelines, and, as you just said, regulations that would be required, right? So again, there's a whole spectrum of can the industry police itself and govern itself, right? So self-governance type of guidelines versus more regulation, right? So you mentioned what are some of the regulations coming through. And one of the things that has happened over the past, I would say, 5-6 years is the European Union has been very active with various committees, academics, policymakers, and corporates in drafting many of these policy documents, right? So, and of course, there are a number of other professional associations like IEEE and others who have also been very involved in looking at the ethical consequences, some of the challenges around these models. So we do have a policy proposal, a regulation, I should say, that is under discussion by the EU members. It's called the Artificial Intelligence Act that was released in April. Various EU members are examining them and also incorporating them within their respective national legislation. So I think it's still probably a year or two from actually enacting in every country, but then they'll also have a rollout. So in addition to that regulation, we see a number of other national governments or policy bodies in these governments coming up with various guidelines. So US is very active, Canada, UK, number of other countries are actively publishing various guidelines. So that also starts impacting data scientists and how they work. So I would say if you're a data scientist, you definitely should be looking beyond just the technical articles into some of these broader ones. Of course, definitely it has drawn. It has what the AI has already done is also drawn attention very much to some of the technical aspects of fairness, explainability, interpretability, and so on. So there's a data science community very much focused around ethics as well.
So, there are regulations, and certainly when you talk about bias, I think most people think about sort of racial bias or negatively impacting a specific community. Are there any other types of biases that data scientists should be aware of? And then is it merely looking at the features and making sure that the data is representative? But are there also other aspects, maybe the types of algorithms that the data science uses that they should be aware of? Like how should we think about both the types of biases and the data sets and then the algorithms themselves?
Yeah, interesting question. So as a data scientist, I think we need to be concerned about a number of related things. You mentioned bias, and there's a recent book by a couple of authors around the notion of noise in human judgment, and also noise in algorithms, which data scientists are familiar about, but also noise in human judgment. So you need to be worried about noise. You need to be also looking at bias. There's also a related concept of fairness. And fairness is much more of a social construct. Bias as a very specific statistical or technical meaning, and similarly, if you like, noise can be categorized in different way, right? So the book by Daniel Kahneman, Olivier, and Kassenstein on noise sort of categorizes the different types of noises in human judgment. So I think that's also important for us to be cognizant of. Now, the bias, I'll just tackle the bias here. Bias can come from different ways, different stages of the model. One is, as we just went through, from just the data. So the sampling of the data, the historical nature of the data might lead to biases depending on what you want to do, right? So again, the notion of bias is also very closely tied with what is the objective of your model. So what is it trying to do? What is the goal or objective that you're trying to minimize, maximize, or predict, and so on. So it depends on that. So that's one way that bias could come in. The other way that people also talk about is lack of diversity in the people who are building the model, right? So again, the algorithm is capturing the various features. The data that you want to include or not include is dependent on both availability as well as, now given the vast amounts of data we have, we make choices on which data to include or which features to include in your feature engineering. So that is very much human dependent. So there's been a lot of work trying to go into what kind of a diverse group of data scientists do we need so that we can make sure that the model development is not biased. Then you can go through both, and still you can have bias just based in the way the model gets used. Some of it could be extremely random, right? So let's say you have a recommendation system which recommends let's say top 5 songs, and let's say it's initializing it. There is no one who has heard it, and you have all 5 of equal value, i.e. 0 people have viewed it, but the ordering matters. So behavioral economics clearly tells us that we as humans, we just go in a certain order, and the ordering matters. And let's say someone randomly picks, doesn't matter which order, they pick one from that. Now suddenly one of the songs has a like of 1 and the other 4 have 0. Now the second person comes in and then starts looking at it and say, oh, no one has looked at the other, so I'm going to listen to the same song. And now suddenly you have a popularity of 2 versus 0, right? So this is just a very artificial scenario, but that's exactly what's happening. Maybe it's not 0, but lower values. It's just people are sometimes picking randomly, but still that could lead to bias. So detecting that bias is also important. And there are some other very interesting biases that come in more because of the system. An interaction between multiple things causes bias. So it's really something that we need to be very cognizant of so that we can be guarding against some of them. I don't think every bias can be prevented. I think we just need to be conscious of what bias we are introducing and therefore how we are using the model. Again, back to my earlier point, that's where the usage becomes important, right? So what is the impact of this model on the broader community? Is it in the health? Is it in their financial status? And that becomes important so that then we can say what is bias. Similarly, on the fairness side as well, there are more than 30 plus definitions of fairness. Again, it's not so much the algorithm that is fair or unfair. It is more our conception of what is fair or not fair. What might be fair to me might be unfair to you, right? So, and that's also becomes much more of a human issue or a societal issue as opposed to necessarily an algorithmic issue. And I think knowing that would help the data scientists as well so that they can have the right conversation with the business stakeholders, because it's not all in a technical solution. I think quite a bit of that is how this model gets used in a broader context, which obviously the business folks know, and that's something that the data scientists should tease out, even if they are not able to articulate, to be able to tease out the business context and the harms and risks that these models could potentially cause so that you can prevent them. So that's why I think it's a very good move that the community is going through in thinking broader. And I think it also, I think you asked me the question around how has things changed from the 80s, 90s to now. That's right. One other thing, right? So it is far more adoption now. So we do need to take into account these societal impacts now more so than before, right? So we were still in the lab, and the consequences of doing things is, hey, I get a paper published or not published, whereas now, right, hey, people are using it. In fact, millions and even billions of people might be using our machine. We better be careful on what we really recommend.
Right. So that's exactly right. Like, I think in a way, the sort of the advent of AI usage and machine learning has created and forced us to have these tough conversations with our business users and with the wider community to also hopefully help educate them on the best ways to put together these models, and also to maybe demystify the models themselves. So I want to recap a little bit. I mean, you mentioned noise and human judgment from Daniel Kahneman's book, and that's basically my understanding is, given the same amount of data, you and I could look at that data set and come to very different conclusions. So that is one area where sort of, something to be aware of as you're building your models. The other is just, fairness. Like, how is fairness defined? I think, again, you and I can disagree on what is fair and what is not fair. I can imagine as a DSL trying to come up with those boundaries, trying to come up with what is fair is a useful conversation to have with your team. That's right. And there's also the background of the modelers themselves, or the data scientists themselves. Just naturally, people I think should be aware that they're bringing their biases into their work, and not just into their political opinions and the like. Right. And then last is, like, when the model's actually sort of implemented, and the end user, so to speak, potentially that model, if it's a recommendation engine or something like that, how you actually display the results of the model. Yep. That interaction point is where bias can also creep in as well. So right. It's important to be aware of all facets of these things as you're putting your models into production.
Yep. Absolutely.
Great. Well, let's move on to our next topic. I mean, this has all been very fascinating. I also want to talk a little bit about your day job too, which is working at PwC. PwC is a large consulting firm, as we all know. So if you were advising somebody who was just creating a sort of a small boutique consulting firm focused on data science, and we'll start there, maybe we'll go to the larger consulting firm, like what sort of, if you were talking to that DSL, what things would you talk to him or her about?
Yeah, so if you're creating a consulting group of data scientists, a couple of key things I would look at is first is, of course, it's all about the people, right? So what kind of data scientists you bring in. Next, it is more around what kind of an environment that you provide them, right? So, and then thirdly, who are the others that are necessary as part of this consulting for you to be really successful with your clients in solving problems, right? So if I take those three pieces, now in terms of how we bring in people, I would say that there are a couple of things that we want to look at in terms of the type of people that you want to bring in. So I would say for a data scientist or an entry-level person, I would look for three specific characteristics. So I call it the 3 C's. So it is the curiosity, the creativity, and the communication are the 3 C's. The reason why it is sort of curiosity is as a data scientist, you should be curious on why something is happening, or how can I tease out some insights from the data? So the data scientist's job, in my view, is teasing out insights from the data. So if you're not curious, I don't think you can be very effective in teasing out those insights. So that's number one. And the second one is a creativity. So you need to be a problem solver. You need to be a creative problem solver. It's not that you're given this data set and you're just running through, 20, these days there's libraries of hundreds of algorithms, run all of them, understand them, and then pick the one that has the biggest accuracy, and so on, and then your job is done.
You don't sound like a big fan of AutoML as an aside.
Yes, that's right. That's fine to some extent, but then you really need to be creative in how you solve the problem and how you sort of go deeper. So creativity is the second one. And the third one is communication, right? So again, for this model to be actually useful, you need to be clear on what actions, what decisions it's going to be driving, and communicate the value of that, communicate how well or otherwise the model is doing, the implications of the model. So communication is, I think, very critical for a data scientist. I would say both the technical communication, so you can stand behind your algorithm, the way you have done it, and so on, but also stand in front of business users, business stakeholders, and be able to explain to them what is happening and how you arrived at and how you took the data, labeled it, did whatever learning mechanism or natural language processing. So all those three become very important. Then two other criteria that we usually look for as people progress in the data science ladder is two more C's, one being a coach and the next one being a collaborator, right? So the coach, because I think it is still very much art than a very much an engineering, or I would say it is a science, but it's also an art of that science rather than everything nailed down like a software engineering practice. So in that sense, the data scientists, as they get more senior, need to be very much the coach and guide to the younger ones to be able to show and guide them on what to look for, what not to look for, where to look for, and so on. Again, we all know it's a very, very active area, so there are a number of algorithms that are coming almost on a daily basis, so you need to be able to play around with it, and that's the other side of the curiosity, right? So, hey, I found this interesting thing. How did they actually do it? Is it a different technique? Is it the technique that I know? Those kinds of things. So coach becomes an important one. And collaborator, right? So the collaborator, again, as you get into the managerial side, you need to be collaborating with other domain experts, other business experts, and so on, because you have the techniques, they have the problems, right? So, and then trying to collaborate with them in understanding and breaking down the problem in a way that you can actually go find the data and do it becomes a critical skill. So I would say these 5 C's are probably critical in both getting the people in and then keeping them there, keeping them enthused. Now, I also said, how do you have the retention in the data science? And one of the key things is it's a very, very dynamic area. And everyone will claim, of course, digital is very, very dynamic, lots of things happening, and there are a number of other areas where a lot of things are happening. But data science is at least one of a few of them where every day there is something new. There's so much of research, so much of papers happening. So in that sense, you need to allocate the right time for your data scientists to what we call as exploration. So roughly, it's not necessarily everyone should do this, but in our team, we have a 60-40% rule, right? So in other words, 60% of the resources is focused around taking some of the ideas as well as problems and then implementing that for our clients, for the businesses, for the clients, basically hands-on application. The other 40% of the time is very much that exploration, reading articles, and then once you read articles, going into whatever the open source, downloading them, experimenting with them, combining it with what you have, and then trying to apply it into some of the problems that you are seeing or potentially might be seeing. So we call them innovation sprints. Explorations and innovation sprints becomes very critical. One is to obviously retain the people, because that's something that people really enjoy. We don't want to lose track of what's happening. But the other thing that's important is otherwise very quickly you can lag behind. And whether you're in a corporate job or especially consulting, if you're working in 5 years old technology and NLP that was there 5 years back, and not kept pace with the new ones. I'm not suggesting that everything that has come now has superseded everything that happened earlier. Definitely not saying that, but definitely you need to be aware of the pros and cons of the different approaches and so on, so that you can bring the best of everything in a consulting environment. So that's the sort of the main part, I would say, that you need to be conscious of as you build your data science group. And finally, the other side of who are the other people, I think one of the key roles that we have is what we call as a bilingual or a multilingual. So what we mean by that is data scientists who are maybe naturally grown into a specific industry sector, financial services, healthcare, any of those industries, or they might be functional experts. I'm a customer service or a customer experience or a risk expert and so on. I think there are people who are either coming in from the business or functional domain, gathering data science knowledge, or data scientists as they get more experience go into that. So those are the kind of bilinguals we call them. But it's not just the data and the business. The data science and the business domain. You might also want technologists, software engineers. You might also want data experts. So you typically come up with a multilingual person who knows quite a bit about a particular domain and data science, but is also has been a software engineer in the past, knows about software, knows about testing, and so on, right? So that is the kind of capability that I think is good for a data scientist group to have. Again, not suggesting that everyone should be multilingual, but the team itself, I think, should be very much multilingual. So you have people who can talk to the business, functional areas, work with the software engineers, work with the data folks, and of course, the bulk of them might still be data scientists, but you need the ML ops, ML engineers, and all of the ops people. So that's how you build a team.
As I was hearing you answer that question, I was trying to think of myself, like, how is what Anand you're describing here different from a data science team, like if I'm building a data science team within a single company, right? Not a non-services company. And what I was hearing was strong emphasis on communication. I think that's so important. I mean, the fact that you call out that's almost a different language, bilingual. Being able to understand a specific vertical or being able to understand a specific function, plus also having that data science background, I think is really important.
That's right.
But I think what makes the consulting industry sort of unique is that as a in this case, a data scientist, as a consultant who's doing data science, you're getting exposed to many different companies, right, and many different problems, and potentially many different verticals.
Yes.
Right. So the type of problem that you're dealing with can really, I think, go a lot broader. But I imagine that as you spend more time at PwC, you have an opportunity to focus, and that's where that sort of bilingual, sort of deeper expertise comes in.
Matters, yeah. And we have what we call as a major and a minor, right? So, and again, the staff are allowed to choose, and that's something that evolves as they go through their career. So the major might be a specific technology. It might be, hey, I want to go deeper into NLP, natural language processing, generation, understanding, or, you know, I want to be more in working with vision, computer vision, deep learning, those areas, sort of more based on the data. Or some might say, no, I want to be more in the simulation, reinforcement learning, agent-based modeling. So that's more a technology-based major, and they might have a minor in terms of a particular functional area, or it might be a particular vertical, or we sometimes reverse it, right? So your primary thing might be banking, for example, but you'll know a variety of different techniques and use cases within banking, which you can bring various data science elements to. And so banking might be your major, and then AI and various areas of AI might be your minor. And you might even have a specific thing there in terms of, I'm a risk expert in a banking environment, so anything associated with risk, I know I can do it, I can bring the right people. So that major minor also works quite well in developing those skills, and then you tend to rotate that, so over a period of time you can build the right balance of expertise.
Got it. And I love the 3 C's: curiosity, creativity, and communication. I mean, communication I'm hearing loud and clear. I think there are some data science leaders that create separate roles, right? Sort of engagement managers who are responsible for sort of doing the translation between the business and the data science team. It sounds to me like your expectation is that the data scientists themselves work on that communication, work on their ability to present their findings, back to the business users. And I think, if in so doing, that's how you get that sort of vertical expertise and potentially, subject matter expertise and so on.
That's right.
I think, totally agree there. Let's move on to our last and final topic. One of my favorite ones on the DSL podcast, which is discussing ROI and AI. So, that's also, very important. We were starting up this new consulting firm, right? Is making sure that like the work that you do for your customers is driving value, right?
Yeah.
So talk a little bit about how should a data science leader think about ROI?
Yeah. So the ROI, and I think the very term ROI, I think we need to dig a little bit deeper from a data science perspective, right? So I know everyone is used with that word, at least in the business world. You need an ROI for whatever systems that you're implementing, or it might just be a program, marketing campaign. For anything, you do need to have the ROI, which is obviously, everyone knows, return on investments. Now, the key thing for data science is to just try and unravel that definition a little bit, right? So what is the investment? What is the return, right? So in one sense, it's all dollars at the end of the day, right? So dollars that you're getting back versus dollars that you're putting in. But I think that's a hard R and a hard I, right? So investment and return. But there are a number of softer things that also come into play, right? So even in the dollar one, if you look at AI analytics more broadly, or data science more specifically, what these models do are fundamentally a couple of things. So one is they improve the productivity of the person using it, right? So some of the automation related ones, and then you can go into RPA, IPA, so robotic process automation, intelligent process automation. Some of those are more productivity enhancing, so which means that you are going to save more time, right? So whatever investment you are doing in building something, the hope is that you will save time. If something took 8 hours to do, you're promising using my system, you can do it in 1 hour, for example, right? So you don't have to completely eliminate it. Let's say it's sort of 1 hour. So time is one. But then people also look at headcount savings, right? So can you actually transfer these time savings into headcount savings? So that gets a little bit tricky. Now, if I'm saving...
You're scaring many of our business audience out there.
Yeah. So that gets very tricky, as you know, is if I'm saving 20% of 100 people's time, right? So can I aggregate all of these 20% and then get rid of a few people? Unfortunately, it may not work that way, right? So if you imagine 20% of your time, if I remove that, you might have other things to fill up that 20%. And there may be no way of measuring what else are you doing that 20% of the time. And again, depending on what you are doing, if it is knowledge work, value-added work, it's very difficult to justify, hey, I'm doing something valuable for that 20% and don't remove these people, right? So headcount reduction becomes challenging, but that's definitely one metric that people use. On the other hand, if I did the reverse, if I take a particular task and if I'm able to eliminate 80% of the work through automation and I'm giving only 20% of the work to the individual, then it might be more difficult for an individual to fill up their time with 80% of quote unquote value added work or whatever that they may be doing. So that's where I think you need to be careful. It's the number of hours saved doesn't equate necessarily to headcount reduction just by doing the simple math there. It really depends on the nature of how you're getting that saving. So this is just on one level, getting deeper. And then, of course, the more problematic one is revenue enhancement, right? So obviously there are a number of measures where you are targeting better, so effectiveness-based data science models, right? So you're recommending things better, you're making better decisions, and so on. So those are adding more to the top line as opposed to the bottom line, right? So definitely there are measures, but you need to be looking at those and then also taking off the things which could have normally happened. So again, typical test learn cycles and control test groups that you should be having. And then the third one, which is more difficult to measure, is experience, quality, and some of those more intangibles. Definitely that has an impact. So this is just in terms of all I was going through was just return. I haven't even gone to the investment side, right? So investment side, people think, yeah, of course, it's the dollars. Yes, it's the people and whatever you pay your people. Yes, some people might count the compute time, the storage time, the storage dollars, the compute time. But then there are other things which are sometimes go hidden. If you're doing machine learning, you need labeled data set. Right? So, and then labeling that, if you don't have a label set and you are going to go and label that, that might be a significant cost. And again, that cost might be maybe a fixed cost upfront to go and do that. But once you have done that, maybe the variable cost is much lower and you can spread it and scale it much better. So now, but you still have to incur this labeling cost, for example, or the data preparation cost. So you need to be conscious of some of those. And then if you go even broader, it depends on what compute you do. I mean, I know everyone is on the sustainability side. Now, you're crunching through all of these algorithms and compute and using more compute time. Does it really had an appreciable difference in the accuracy? If it is only 1 percentage point difference for a huge amount of compute time, is it really worth it? And how do you know, or how do you determine whether it's worth it or not without doing it, right? So that's why you need to compute that rather than saying, I'll run all my deep learning algorithms and everything that I need to run and then determine. So just on this ROI, I think trying to piece it down into hard and soft factors on the return and investment is one task. Then there's a secondary issue, which is also very important. And that is about when you say a data science model is performing better, the question is better than what? So all of the ROI measures are the algorithm does better than a human. Now, that's easy, very understandable to everyone, but which human, right? So is it your, let's say you're in an insurance company, is it your best underwriter? Is the algorithm performing better than your best person? Is it one person or is it a group of people, all your underwriters? Or is it better than the average? Or is it better than your entry-level person? All of them might have various values, but you need to be clear going in as to what ROI you are expecting. So when you try and measure the ROI for an initiative, you need to have an understanding, because that changes how you're running your testing and your data science model, right? So the person who should be testing is not someone who just joined your company as an underwriter, is not the one that you are measuring against. You need to get your average underwriter to be the person who is testing and validating your system from a user perspective. So it becomes important as to what the ROI is and against whom you're measuring. Then there is a further complication. Even if you decide which group it is, you might still have lots of noise. And this is where I think the book Noise sort of highlights there's a noise with respect to multiple people on the same problem. There is noise with respect to the same person, same problem, depending on the time of the day and your moods,
right.
You might do different things. And then, of course, different problems of different people are also different, right? So all of those things also have to be weighted in doing the comparison. So again, it's a sort of a can of worms, as you can see, that unravels. So that's a sort of the second aspect. So one is what is the ROI definition, soft, hard aspects of it. And then, of course, what is the baseline and how are you comparing that baseline? And then the third set of issues is, I think, this is where I think data science is more of a science than an engineering, right? So it's not software engineering, it is data science. The reason why it is I think if you go back to pharma, life sciences, and drugs, there's a huge number of formulas or drug formulas that are tried, and a very small proportion comes out at the other end and approved by the authorities, right? So, and that whole process takes literally 10 years and billions of dollars. I'm not suggesting data science is like that, but in some sense it is test and learn, right? So you have various phases. You need to divide up your way in which you are thinking into multiple phases. So in other words, you should think of your data science as a portfolio, data science projects as a portfolio, so that there are some projects which are, I guess, tested, truly tested now. So sentiment analysis, so pulling out recommendation engines or chatbots. Not that it's quote unquote easy, but we know that there are hundreds, if not thousands of companies have done it. Given the right data, given the right team, you can build it, right? So there's some of those where you can expect an ROI based on the experience you can determine. But at the same time, you want to be pushing the boundary into some of the newer areas, right? So areas where, let's say, you are embedding reinforcement learning within a simulation system, digital twins. So it's exploring newer techniques. So you need to have a balance of your portfolio. And what we also recommend is, as a person who runs a data science unit, don't go and promise an ROI on every little project to your stakeholders. Take it as an overall portfolio, and then say, for this portfolio, for this investment into this portfolio, I'll get you this return. So there might be some models that might be quote unquote blockbusters. In other words, they'll save huge amounts of money to the firm or might generate a lot of revenue. There may be a few which just fail, and that's okay, right? So, and I think we need to have that portfolio mentality as opposed to having our data scientists define exact ROI for every data science project and insisting that there X number of hours are spent and you have Y% accuracy and you need to generate Z dollars at the end of the day, is not going to really work. And if your measurement is structured that way, I'm pretty sure you're bound to fail, because data science is still not an area where it is clear cut like that. It's very much a science and an exploration. It's an experiment that you're running, and then make them successful.
Yeah, I think if you look at it just project by project, you run the risk of being very cost conscious, right?
That's
and
right.
You have that one bad project. Whereas if you look at the entire portfolio, man, I'm sort of sounding like, I don't know, a financial advisor, who's
Yes.
advising, but I think it makes, there is truth to it, right? Which is like, you're not going to win them all. And if you take a broader perspective, it's the right way to go because there is a test and learn approach to this, and there are sort of unforeseen circumstances. Also, as you were talking through some of the the harder benefits on the R side of the ROI analysis, like hearing about productivity and potential headcount savings. I also think too there's a combination, right? The human in the loop, like the machine, the AI model plus the human. If you're just comparing against even your top underwriter to a model, the third sort of wheel is like, what if you combine both? Like, what if the underwriter was using the model to inform their decision, right? And that I think also is really interesting. And like we don't have time today, but if we did have time, I would be very curious to hear about what that, like, rolling that out and what that might look like.
That's right. Yeah.
What are the advice you have? But that might have to be an episode for another day.
Yeah, no, that's a very interesting issue. Yeah, that's a very interesting issue.
Yeah. Well, we touched on a lot here today. Anand, I really appreciate you taking the time. I mean, we talked about obviously just about the ROI analysis. We also talked about responsible AI. We talked about building out our consulting practice here. I learned a lot, and I really appreciate you being on the DSL podcast.
Thank you very much for having me, Dave. Enjoyed the conversation. Thank you.
Great. If people want to reach out and get chat with you, is LinkedIn one of the better ways to do that?
Right. Yeah. LinkedIn would be
perfect.
Great.
Thank you very much.